The electrical code allows a dining room to share a circuit with the kitchen, but only under specific circumstances. The primary concern is the total load on the circuit. This load must not exceed 80% of the circuit's ampacity. Ampacity refers to the current carrying capacity of the wire, typically measured in amps. For example, a 15 amp circuit should not have a continuous load exceeding 12 amps, which is 80% of 15 amps. Similarly, a 20 amp circuit should not exceed 16 amps, which is 80% of 20 amps. To determine the total load, add up the wattage of all appliances and devices that will be connected to the circuit simultaneously. Divide the total wattage by the voltage of the circuit, which is typically 120 volts in residential settings, to get the current in amps. Ensure this calculated current does not exceed the 80% threshold. Secondly, the circuit must be properly protected. This means it should be equipped with a circuit breaker or fuse that is appropriately rated for the circuit's ampacity. A 15 amp circuit needs a 15 amp circuit breaker or fuse, and a 20 amp circuit needs a 20 amp circuit breaker or fuse. The purpose of the circuit breaker or fuse is to interrupt the flow of electricity in the event of an overload or short circuit, preventing damage to the wiring and reducing the risk of fire. Using an incorrectly sized breaker or fuse can be dangerous. A breaker that is too large will not trip when it should, potentially leading to overheating and fire. A breaker that is too small will trip frequently, causing nuisance outages. Thirdly, the shared circuit should not supply any other heavy appliances. Heavy appliances are those that draw a significant amount of power, such as refrigerators, dishwashers, microwave ovens, and washing machines. These appliances typically require their own dedicated circuits to prevent overloading the circuit and causing voltage drops, which can damage the appliances. If the circuit is already supplying one or more of these heavy appliances, it is not permissible to add the dining room receptacles to the same circuit. If the dining room has more than 3 receptacles, then it must be on its own dedicated circuit according to the electrical code. This requirement is designed to ensure that the load on the circuit does not become excessive, particularly if multiple appliances or devices are plugged into the receptacles simultaneously. The specific number of receptacles that trigger the dedicated circuit requirement may vary depending on local codes. It is always best to consult the local electrical code or a qualified electrician to determine the specific requirements in your area. The National Electrical Code, or NEC, provides guidelines and standards for safe electrical installations. Local jurisdictions may adopt the NEC as is, or they may modify it to suit their specific needs. Always refer to the local electrical code for compliance. If the dining room lighting is also connected to the circuit, that needs to be factored into the load calculations. Lighting can contribute significantly to the overall load, especially if it includes incandescent or halogen bulbs. LED lighting is more energy efficient and draws less current, but its wattage still needs to be included in the total load calculation. Consider the potential future use of the dining room receptacles when determining whether to install a dedicated circuit. If you anticipate using high-power appliances or devices in the dining room in the future, it may be wise to install a dedicated circuit now to avoid having to do so later. When calculating the load, use the nameplate ratings of the appliances and devices. The nameplate rating is the maximum power consumption of the appliance or device, typically expressed in watts or amps. This information is usually found on a label or plate attached to the appliance or device. If the nameplate rating is given in amps, multiply it by the voltage of the circuit, typically 120 volts, to get the wattage. It's also important to consider the type of load. Continuous loads, such as lighting that is on for extended periods, should be calculated at 125% of their actual wattage. Non-continuous loads, such as appliances that are only used intermittently, can be calculated at their actual wattage. Consider the impact of voltage drop. Voltage drop occurs when the voltage at the receptacle is lower than the voltage at the circuit breaker due to the resistance of the wiring. Excessive voltage drop can cause appliances to operate inefficiently or even damage them. The amount of voltage drop depends on the length of the wiring, the gauge of the wiring, and the current flowing through the wiring. The electrical code specifies the maximum allowable voltage drop for branch circuits. To minimize voltage drop, use appropriately sized wiring. Thicker wiring has a lower resistance and will result in less voltage drop. If you are unsure about any aspect of electrical wiring or the electrical code, consult a qualified electrician. Electrical work can be dangerous, and it is always best to err on the side of caution. A qualified electrician can assess your specific situation and provide guidance on how to safely and correctly wire your dining room receptacles. Furthermore, many jurisdictions require a permit for electrical work. Before starting any electrical work, check with your local building department to see if a permit is required. Performing electrical work without a permit can result in fines or other penalties. The electrical code also addresses the type of wiring that is permitted for use in residential wiring. Typically, non-metallic sheath cable, also known as an N cable or Romex, is used for most residential wiring. An N cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. The size of the conductors in the NM cable must be appropriate for the ampacity of the circuit. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit typically requires 12 gauge wire. The electrical code also specifies the types of receptacles that are permitted for use in residential wiring. Typically, 15 amp or 20 amp receptacles are used, depending on the ampacity of the circuit. Receptacles must be properly grounded to prevent electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Arc fault circuit interrupters, or SIs, are often required for circuits that serve dwelling units. SIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. SIs trip the circuit breaker when an arc fault is detected, preventing a fire from starting. The electrical code specifies where SIs are required. Ground fault circuit interrupters, or GFCIs, are required in locations where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. GFCIs detect ground faults, which occur when current leaks from the circuit to ground. GFCIs trip the circuit breaker when a ground fault is detected, preventing electrical shock. In summary, to determine if the dining room can share a circuit with the kitchen, firstly calculate the total load on the circuit, making sure it does not exceed 80% of the circuit's ampacity. Secondly, ensure the circuit is protected by the correctly rated circuit breaker or fuse. Thirdly, verify the circuit does not supply any other heavy appliances. And if the dining room has more than 3 receptacles, a dedicated circuit is likely required. Always consult the local electrical code and a qualified electrician for specific requirements in your area. Electrical safety is paramount.